Okay, let's do a refresher on lns. So if given y is equal to ln of x, well, what does that mean? Well, what's the base of ln? The base of ln is e. So e to the y is equal to x. E to the y is equal to whatever's stored inside the ln, x. Another way of looking at that is to say, okay, if y is equal to ln e, or sorry, if y is equal to ln x, then what is e to the y? Well, we could say e to the y. We don't know what it is, so we say, okay, sub in e. Now y equals ln x, so this is ln base e to the x, correct? That's what y is. Well, look, this e to box, right? This is the exponent. So e to the box is x. So this e to this box is equal to x. Therefore, this e to this box must be equal to the same thing. That's why it equals x. Okay? That's another way of looking at it. So let's zoom in again. Look. Okay? I'm gonna do this again. So we can say e to the y is equal to x just by looking at this is how ln works, right? Or you could say, okay, if you have here, let me start over for a second here and say, I'm gonna delete this. Okay, let's say we don't know what e to the y is. Let's say we just say, okay, what is e to the y if y equals ln x? This is a base e to the x. Okay, so this base e, okay, so this ln of x is equal to box, right? So if this e over here, the base of the ln to box here is equal to x, well then so is this e to this box. That's what it is, right? This ln of x is the box, right? So that means that it equals x. All right. Okay, let's do another common mistake here that we tend to see every year. All right. So if look, this is exponents. E to the a plus b is the same thing as e to the a times e to the b. Correct? Okay. Right? So what if a was some constant, and you're going to see this a lot, e to some constant plus ln of x. We tend to see this a lot. So that's equivalent, using the same rule above, is e to some constant times e to the ln of x, right? And we said that we already know this one, right? E to the box is x, so this e to this box must be x. Okay, so this one is x. E to some constant, well, that's just some other constant, right? We'll call it c naught. Okay? Or c1, or whatever we want to call it. Maybe we'll call it c1. Okay? Just to be similar to our notes. Okay, so that's another thing. Well, what else? What else do we see that people have made mistakes on before? Let's look at another thing. Okay, let's delete this one. All right. So look, if f, oops, back to pen. So if f of x is given by ln x, what is the derivative? F prime of x is equal to d by dx of ln x, right? What is that? Well, that is 1 over x, right? Okay, that's fine. So what if, so let's say you want to do a u substitution. Let's say that's not as simple as u, okay? So we have some function of u, okay, is equal to ln of u, okay? So then, now what is f prime of u, where we're talking about with respect to x, d by dx of f as a function of u? Well, what you need to do for that is you need the chain rule, right? So what, and sometimes you need u sub. So here, what we need to do is say d by du of the function as a function of u, and then we cancel out that. We say du by dx. So you see how this du right here cancels with this du, so it's the same, it's still d by dx of the function of u. So we haven't changed anything there, but we're using the chain rule. Okay, so now we know that d by du of f of u, well, we know that that is ln of u, right? And then, it depends, sorry, f of u is ln of u, so this is, 1 over u, right? 1 over u. And then this is times du by dx. Now this just depends on what, how u is related to x, okay? Let's look at just a few examples just to work this out. So let's clear the canvas. Let's do an example. First example here is what is if f of x equals ln of x squared plus 5. Okay, here we got to do a u substitution. So we're going to say let u is equal to x squared plus 5. So this is a u substitution. So now we have f of u, right? So f of u is equal to ln of u in this case, right? So what is f prime of u? Well, that is d by dx f of u, right? So what is that? Well, that's equal to, you need d by du of f of u times du by dx. Okay, this is just chain rule here. So what is d by du of f of u? Well, we know this to be, this is 1 over u, okay? And then we need du by dx. Okay, so what's u? Well, we have that right here. So we have 1 over u. We can back sub x squared plus 5 for u. And then we need d of x squared plus 5 by dx, which is just 2x. So at the end of the day, we have 2x x squared plus 5. Okay, so this is my f prime at u, or it's the derivative of that function, right? F prime, it's f prime now, it's as a function of x, okay, because we've converted everything back. Okay, so that's an example. Another thing that I wanted to show you, let's take a look at another thing we can do. Let's clear the canvas. All right, so there's an integral that we're going to see in this course that kind of shows up quite often in the course, and that is basically that you have a numerator that is approximately the derivative of the denominator. Divided by the denominator. Okay? Usually it's some function dx. Okay? Now, this right here, if the derivative of a ln is 1 over x, then the integral of something that looks like a 1 over x is a ln, right? Okay, so the best way to kind of learn this is by looking at some examples. Okay, so let's take a look at some examples, and they're going to involve u substitution, and then you're basically you're doing the inverse of what we did with the ln, right? If you have something related to a 1 over x, then it's going to involve some u substitution, okay? So let's go in here. So if you have, okay, look, this is just a simple example. Integral of 1 over x dx is what? Well, because the derivative of, if you take the derivative of ln x, you get 1 over x, right? So if you integrate 1 over x, you'll get ln x, right? So this is ln magnitude of x. Now, every time you integrate, there's an integration constant plus c. Okay, let's look at another example here. So you see, this is approximately the derivative. Let's look at another one just to make it a little more clear. Actually, let me make some space here. Let's continue. So imagine you have this next integral. Okay, 2x divided by x squared plus 1 dx. Okay, look, the numerator is exactly the derivative of the denominator. What's the derivative of x squared plus 1? You get 2x. Okay, so when you do this, what you can do is you can do a u substitution. So you say let u equals x squared plus 1. So what is du by dx? Well, that is 2x. And if you multiply both sides by dx, and this cancels, so you get basically what du is. You get du is equal to 2x dx. Okay? So what does that mean? That means I can directly sub these guys into this equation, right? So 2x dx becomes du, and x squared plus 1 becomes u. And we already did that up here, right? Just x is u up here. This is just ln of u plus c is the solution, and then you sub back in your u, right? So this equals this, and then you're going to sub back in for u. The solution becomes ln, what's u? It's x squared plus 1, right? Plus some constant, okay? All right, this is one that we kind of going to see. Let me clear this out a bit. I'll look at a couple more examples for this. Okay. And delete that. Let's look at another example here. So let's go integral, and you're going to see something like this later. So sine of x over cos of x dx. Okay, so what's the thing here? So this again, look, cos and sine are related. Sine is some derivative of cos, right? It's related in some way. So let's say that we let u, remember it's the same thing. You have a denominator and then you have something in the numerator that's related as a derivative of the denominator. So if we say let u, because it's the denominator, right, is cos x, what's du dx? Du by dx, what's the derivative of cos? Is negative sine x, right? And then if you multiply both sides by dx, right, then this side, basically these two cancel. So then we have du and you have u. So now we can take u and du. So look, we have, what do we have? We have sine x dx. We don't have negative sine x dx, right? Sorry, I'm on a little bit of an angle here. Okay, so what we have, we really have negative du, right? This is what we have, right? In our equation, we have sine x dx. This is negative du, and we have u directly here as cos x. So again, this looks like, okay, we have a negative du. So I'll put the negative here. I'll put the du here, and then I have 1 over u, right? And then we know this already, right? This right here is, okay, we can keep the negative. We'll say negative. And then this is ln of u, right? plus c, right? And what's u? It's cos x. So this is negative ln of cos x plus c. Okay? Let's do another example. Let's do a couple more in here. Delete this one. All right, same idea. So let's go with this example. We'll say x squared over x to the 3 minus 5 dx. Okay. And sorry about the x. Okay. So what's u? Again, we always, in this case, because you have this guy looks like some sort of, it's related to the derivative of this guy. So we know that we want to make the denominator u. So let u equal x cubed. Sorry, I touched it with my finger. X cubed minus 5. So what is du by dx? This is 3x squared, right? So now I multiply both sides by dx. Okay, and then these guys cancel, so I'll erase that. That's my du. But what do I have? I have x squared dx. I don't have 3x squared dx. So really, if I divide both sides by 3, I can get rid of this. So I have x squared dx, so I have du over 3, and then I have u. So I can take these guys and sub them in now. So what I have, x squared dx is, okay, I'll put the 1/3 out, right? I'll take it out, and I have du. So I have 1/3 du with the x squared dx, and then I have, with the x cubed minus 5, I have u. Okay, so really what I have is, I have the 1/3, and then I have ln of u plus some constant, right? Now 1/3 times that constant might be something else, but so I'm going to sub back in the u into here. So I have 1/3, I'll put the ln, I'll put the x cubed minus the 5. Now the 1/3 times the c is just some other constant, so I'll just call it c naught, let's say. Okay? So that is the solution, right? All right, so that's how you integrate that one. All right, so let's stop there. Actually, let's do one more. I'll delete this one. Okay, I'm gonna do one a little bit more complicated. So we have, oh, I touched it, but I didn't have a pen. There we go. Okay, so this one is going to be a little more complicated. So we're going to go integral. We have x to the 3. Okay, x to the 3 cos x to the 4 over sine x to the 4 dx. All right. So now what do we do? Okay. Well, again, we have something that looks like the numerator looks like some sort of derivative of the denominator. That's how we have to do it. So let's go in here. Let's say u, it's got to be the denominator. So we let u be sine of x to the 4. Okay, so what is du by dx? Well, in this case, what we have is we have, well, du dx is like this. Look, du dx is the same thing as d by dx sine of x to the 4, right? But we can't really do that yet, right? We have this guy as an x to the 4 and this guy's a dx, right? So what we need to do is we need to use the chain rule. We could do the chain rule again, right, if we wanted to, but I'm going to do it even simpler. What I'm going to say is, I could say v I can say let v equal x to the 4, right? Okay, so then this becomes, what I'm basically doing is I have to go d by dv sine of v times dv by dx, right? So then when I have this dv and this dv, they cancel each other and I haven't changed anything because v is x to the 4. Okay, so, all right, so what do I have? Well, what's the derivative of sine? The derivative of sine is cos v, right? And v is really x to the 4. I could put v back. I could put x to the 4 here. Okay, sorry, this is x to the 4. I'll put that back. And then v is dx to the 4 by dx, right? Okay, and this is du by dx, right? Okay. Well, what is dx to the 4 by dx? This guy is equal to what? Let me just, let's take this out. So let me just continue this. This is cos, it looks like it deleted there. Cos x to the 4. This is 4x to the 3. Okay? So this is du dx, right? So if I wanted du, I need to multiply both sides by dx. And then this guy will cancel. Okay, and then this guy stays there. And look, I have x to the 3 cos x to the 4 dx. So this 4 is sort of extra. So if I divide both sides by 4, I can cancel out this 4. Okay, so what I have here, I have cos x to the 4 x to the 3 dx. Okay, that's the same. Cos x to the 4 x to the 3 dx. That's du over 4. And I said that sine x is u. So really what we have here is we have a 1 over 4. We have a du, right? And then we have a 1 over u, because sine x to the 4 is u, right? 1 over 4 du is everything up here. 1 over 4 du, and then the 1 over u is here. So then this becomes 1 over 4. Here we have ln of u. What was u again? It was sine x to the 4. So let's just put that in. Okay, plus the c. Sorry about the little bit of a mess there. And this becomes the solution. Okay? Now, we will at a later time take a look at integration by parts. This may be necessary to solve differential equations. I'm sure you've seen it before. I just wanted to review it with you. We'll do that a little bit later.